Okay. Can you guys hear me? Please tell me. I'll give you my introduction. First, let me know. Can you guys hear me? Good evening, good evening, good evening. Just a quick. Okay. So audio video is clear, right? Audio video is clear, guys? Okay. Okay. So welcome to this class. A new day, new chapter. My name is Fez, and I'll be teaching you the chapter Gravitation. So are you guys ready for this chapter? Pretty interesting chapter according to me. Are you guys ready? Okay. So, good evening, guys. So, what are we going to study in this chapter? First of all, in class 11th, we studied this chapter, right? Sorry, in class 9th, we studied this chapter. Newton's laws of gravitation and some numericals related to that, right? We are going to dive means we are going to go deep into the subject in class 11th. All right. So for today's class, we are going to study Newton's laws of gravitation, which we already studied. We are going to revise it. Okay. Acceleration due to gravity. What is acceleration due to gravity? What actually it is? How the value of G comes out to be 9.8 meter per second square. We are going to see in that. All right. And how that G varies. Means in what condition the value of G varies. Okay. Changes. So is that clear? Is the outline of today's class clear, guys? Can you tell me? Is the outline of today's class clear? What are we going to study? A little responsive would be nice. Hello, hello, hello. Okay. So have you guys do you guys know this guy? Who is this guy? Newton, right? So you have probably heard the story about Newton. He was sitting under a tree, an apple fell on his head. Okay. After a little trauma on his head, he found the theory of gravitation, right? But that is actually not true. What happened was he was in his office, okay, and outside his office, now there was an apple tree, okay. So he saw an apple fall. It did not land it on his head. He just saw an apple fall. All right. And the fun fact is that tree is still there. Okay. In the college, he used to teach now in the university. That tree is still there. Okay. So what is Newton's law of gravity? Okay. So what Newton proposed was if you take two masses, yeah, if there are two masses, let's say mass m1 and mass m2. All right. What will happen is can you guys see my screen? Is it visible? Just let me know once. Because suddenly a notification popped up that people can see your screen now. Was it not visible before? Can you guys let me know? Hello. Is my okay, okay, okay. Thank you very much. Thank you very much, Shri. Now, what happens is, just focus on the video part. Okay. What happened is, if we take two masses, intrinsically Newton said that they are going to attract each other. Newton did not give any explanation about why do they attract each other, what is going on that they attract each other. But he said if there is a mass m1 and there is a mass m2, all right, what are they going to do is if you leave them in the open space, they are going to attract each other. Okay, and they are going to, combine. Is that clear, guys? What is Newton's theory? Is that clear? He did not provide any explanation for it. Why does it happen? No, at that time, nobody knows. Okay, today we know. I'll let you know why that happened at the end of the chapter. But for now, why does that happen? Nobody knows. Okay, according to Newton, nobody knows. Now, what he proposed was, for example, if there is a mass m1, let's say our Earth is mass m1, our moon is mass m2. So the force between them, the force acting between them is going to be directly proportional to product of masses. This is experimentally seen. All right. And force is inversely proportional to the distance squared. Means the distance between the two bodies. If they are massive bodies, then the distance between their centers. Okay. What is our distance between bodies, or I can say centers? All right. Okay. So I think this is clear. Now, if we combine these two, what will happen? Can anyone tell me? If we combine these two proportionalities, we'll get F is proportional to M1 by M2 divided by R square. Okay. This relation, by the way, the second proportionality is also called inverse square law. What is it called? Inverse square law. Means the distance is, since they are inversely proportional, and force is inversely proportional to square of distance. That's why it is called inverse square law. We will see this in the next year as well. Okay, in electrostatics, same thing. Hopefully this is clear. Now, if you remove this proportionality, you'll get a constant which is G, capital G, M1, M2 by R square. What is capital G here? Capital G is called universal gravitational constant. All right, universal gravitational constant. Okay, can you guys tell me, let's discuss a little more curious thing. Ki Newton said ki these masses will attract each other, right? But can you guys guess why do they attract each other? Can anyone help me or tell me? Come on. Anyone? Why do these masses attract each other? What is going on between them that one mass is kept here, another mass is kept on another place, and something is going on that they are attracting each other? What is going on? Okay, so I'll give you this question as a homework. Okay, think about it. Yeah, gravitational force, but what is going on? Okay, what is the mechanism of gravitational? In chemistry, you have studied mechanism, right? For example, if I say NaOH plus HCl. So we all know what happens. It becomes NaCl plus H2O, right? But we also study mechanism, right? When you'll study the organic chemistry in depth, you'll see there are mechanism for every reaction. How electron is going from one to another, how they are changing from one to another, and why they are doing that. वैसे ही I'm asking you, what is happening that these two masses are attracting each other? What is the mechanism between them? All right, you have to think about it, search for it, and just let me know. Okay, how gravitational force acts. Yeah, what is the science behind gravitational force, if you may? So that is your homework. Just think about it. Now, the value of this G is, can anyone tell me what is the value of this G? Value of G, guys? Okay, I'll tell you, 6.67 into 10 to the power minus 11 Newton meter square per kg square. This unit is very important because in both JEE and NEET, sometimes a question comes which is related to dimension. Okay, and this use of this G will be very important. Use of this unit will be very important. Okay, now let's calculate the dimension of G. Dimension of this G. Okay, using this what do you say, unit, can we calculate that? Yeah, pretty easily. So what is the unit of G? It is Newton meter square per kg square, right? Newton meter square per kg square. What is the dimension of Newton? Newton means force. It is mLt minus 2. What is the dimension of meter? It is L2. What is the dimension of kg? It is mass, right? So M2. So you can see mass and one mass cancels out, and you are left with M minus 1. Okay, one mass will remain down, right? M, it will go up and it will be M minus 1. L cube T minus 2. This is the dimension of G. This is very important. Note it down. First, what you have to note down, Okay, let me tell you. First, you have to note down this. Newton's laws of gravitation. First, put the heading, chapter name, gravitation. First thing, Newton's laws of gravitation. All right. After that, just write this down. Make this diagram. Don't make Earth and Moon. Just make two masses like I made here in this, like I made here, right? The distance between them is R. Make this diagram and then write these steps. And after that, just write this value of G and dimension of G. Okay, you can take screenshot as well if you want. I'll just pause it for 5 seconds. 5, 4, 3, 2, 1, 0. Hopefully you have taken the screenshot. Now, for the other slide. 5, 4, 3, 2, 1, 0. Hopefully you have taken the screenshot as well. Okay, just note it down. It is very important to note things down. Okay, now before moving ahead, just recalling you, what is force G m1 m2 by r square, right? Okay, what is the vector form of this force? So how to make something a vector? So before that, can I ask you a question? What is vector? Can anyone tell me what is vector quantity? What is vector quantity? What do you mean by vector quantity? There is something called scalar quantity. There is something called vector quantity. So what does vector quantity mean? Can anyone tell me? Okay, very good. Very good. Vector quantity is any quantity which has magnitude as well as direction. For example, force. If I ask you to apply force, yeah, very good. Third property, it follows vector algebra. So if I tell you that apply force, let's say apply force somewhere. Okay, so you might have two questions in your mind. First is, sir, how much force do we have to apply? Second is, sir, where do I apply the force? Right? So you are asking for the magnitude as well as the direction. Right? So vector is a force is a vector quantity by that sense. It requires magnitude and direction, and also it follows vector algebra. Very good answer. So this f, if you see, this f is a, what do you say, scalar quantity, right? F, it is just the magnitude. So if I have to make this a vector, if I have to add an arrow on the top, in this magnitude, I have to add a direction, yes or no? And the direction is given by, it's very important, by a unit vector. Okay, direction is given by a unit vector r cap. So this is the vector form of Newton's law of gravitation. So note it down. This is very important. What is the vector form of Newton's laws of gravitation? Just multiply r cap or unit vector. Just multiply this unit vector in the magnitude. So this is the magnitude. I'm writing it down here. This is the magnitude and this is the direction. Together they make this quantity as vector quantity. Hopefully this is clear. Do you guys know what is unit vector? Do you guys know what is unit vector? I'll explain you if you don't. Okay. Have you guys seen that boards on highways, those green color boards, right? There are boards on highways which say, okay, like arrows. They have arrows, right? Which says, okay, Bangalore is 200 kilometers, Mysore is 500 kilometers, right? So what does this board is doing? What is this board doing? Board is just telling you the direction, right? It's not going with you, right? So unit vector is the same thing. It just gives us the direction. It has a magnitude. Unit vector, as the name suggests, it has the magnitude 1. Okay, it has the magnitude 1. So when we multiply it, no effect. But on multiplying, magnitude wise, it does not affect anything, but it gives the whole magnitude or direction. Is that clear, guys? Is that clear? What is unit vector? Okay. So also we know unit vector is equals to vector upon magnitude of vector, right? Some vector upon its magnitude is called unit vector. So substitute that here. What will we get? We'll get f is equals to G m1 m2 by r square, and r cap, we had that. Now again substituting m1 m2 by r square into r vector by r. So these two will combine, r square and r will get combined, and it will gives us r cube. So this is very important formula. This is the vector form of Newton's laws of gravitation. Hopefully this is clear, guys. Is that clear? Please note it down, vector form of Newton's law of gravitation. Vector form of Newton's law of gravitation. Hopefully this is clear. Is that clear? Give a thumbs up or a yes or anything will work. Is that clear, guys? Yeah? Anyone? How many students are there? Okay, there are few. Okay, so let me give you a question. Okay, let us solve a question. Before that, just take a screenshot. I'm giving you 5 seconds. 5, 4, 3, 2, 1, 0. Okay, hopefully you took the screenshot. Now what I'm going to do is we are going to solve a question. Okay. So what is given is there is a square. Okay. Yeah. This is a square and each length of the square is A. Now on each corner there are masses situated. Okay, mass M are kept on each corner. For example, this is mass M, this is mass M, this is mass M, and this is mass M kept on each corner of this square. Okay, 4 masses are kept on each vertices or corner of a square of side A. What you have to calculate net gravitational force on mass M. Okay, on any mass M you have to calculate the net gravitational force. So try it once. I'm giving you 1 minute to try this question. Okay, just 1 minute, guys. We are on a bit of a time crunch, so 1 minute would be fine, I guess. After that, I'll give you one question, similar question as homework. All right. So try this. I'm giving you 1 minute. Try this question. Okay, let me solve it then. All right. I'll solve this question now. It's my turn now. What I'm going to do is first I'm going to take this whole system out of here. I'm going to shift it down a bit just to make it bigger. Yeah, I think this would be sufficient. Now, for this type of question, let us assume we take this guy, this mass as origin. Okay, we take this as origin. Now, what this will do, this mass, and we have to calculate, let's say, force on this mass. All right, we are going to calculate force on this mass. On any mass you calculate now, the force will be same. The magnitude of force will be same. All right, you can take anyone. I am taking this one. Okay, you can take anyone. I am taking this one. Now, this let's name them, right? Let's name them. This is, let's say, first mass. This is first mass. This is second mass. This is third mass, and this is fourth mass. Force on second, listen to me carefully, force on second due to first. So that will be in this direction, right? In this direction, there will be a force on second due to first. Yes or no? Right? Okay. In this direction. Now, force on second due to third, that will be in this direction. Yes or no? Okay. it will be in this direction. Now, attractive, since they will attract each other, right? So force on 2 due to 1 will be in this direction, left side. Force on 2 due to 3 will be on upward direction. Force on 2 due to 4 will be along this diagonal, right? Will be along this diagonal, like this. Now, since this is square, can you tell me what is this angle? Can anyone tell me what is this angle? And in the YouTube live chats, you can tell me. All right. I'm listening to the chats as well. So you can just give the reply as well if you're seeing there. If you're on the Zoom case, then you can reply here as well. Can you tell me what is this angle? 45 degree is the correct answer. Very good. Okay. The whole angle is 90, right? The diagonal bisects the whole angle, then 45. Now what I'm going to do is, if this force is F, and this will also be F, right? See, this force is F, this will also be F, and okay, let's calculate this F first. Okay, let's calculate this F first. So F will be G M1. Mass 1 is M. Mass 2 is also M. So up M square upon distance between these two masses is A square. So force 1, let's say this is force 1. Force on 2, let's say this is force on 2 due to 1. Force on 2 due to 1 will be gm square by a square. Can you tell me what will be force on 2 due to 3? See, force on this 2 due to 3. What will be the value? Force on 2 due to 3. Tell me, guys. What will be the value? Force on 2 due to 3. Okay. So that will be equal to G m1. Mass is m. Again, second mass is also m, so m square. And distance between 2 and 3 is again a, so a square. Hopefully this is clear, right? Now, what I'm going to calculate? Force, this force. This is F23, this is F21, and this is F24. Force on 2 due to 4. Force on 2 due to 4. That will be equal to G m1, m2 are again m and m, so m square, and the distance between these two will be, what will be the distance between? Yeah. What will be the distance between these two? I don't get your doubt. Is that a doubt, Shri? Shrika Kulam. Am I pronouncing your name right? Because I'm very bad with names. F21, is that your doubt? Just let me know in the chat, okay? So F24, what will be the, okay. Thank you very much. So F24, what will be the value? I'm just asking the distance between mass 4 and mass 2. So we can easily calculate that using Pythagoras theorem, right? I'm just removing these masses force here. See, this is A and this is also A. I have to calculate this diagonal, right? So that will be equal to, let's say this diagonal is D. So D is equals to A square plus A square under root. So that will give us root 2A. And A is outside. Okay, so let me write it this side. So that will be equal to A root 2, right? The distance between 2 and 4. Okay, so that distance square, yani root 2A whole square. So that will give us gm square by 2A square. Root 2 square will be 2 and A square equals to A square. A ka square is A square. Simple as that. Now, what we have to calculate, let me draw that diagram once again here. Okay, let me draw that diagram once again. Yeah. There were 4 masses. One is here, one is here, one is here, and one is here. Again, so there are forces, right? First force is, can I say, first force is here in this direction, right? Let me just, yeah. Second force is in this direction, and third force is in this direction. Now, if I make coordinate system, okay, if I make coordinate system, let's say this axis is y-axis and this axis is x-axis, right? So this force means force force on, what was this force called? This force was called F23, right? F23 is in y-axis. F21 is in negative x-axis. But this guy, this guy is in center of both the forces. Nah, it's not in x-axis nor in y-axis. Neither in x-axis nor in y-axis. So what we have to do for F24? F24 is that student who is not listening to any teacher, nor X teacher, nor Y teacher. Okay, so what we do is we bend them, right? We full, we okay, so we bend them such that we convince them to follow both the teachers. All right, so how do we do that? Let's say this angle is 45 degree, right? So we take component of this in this direction. So in this direction, the component will be equal to F24 cos 45. If you are going towards the angle, all right, if you're going towards the angle, then the component becomes cos on that angle. If you are going here away from the angle, then here you'll get one more, that will be equal to F sine 45. F24 sine 45, right? Now, in x-axis and in y-axis, these are some standard steps which you have to follow, okay? In x-axis and y-axis. In x-axis, who is there? In x-axis, there is this guy, right? Sorry, F cos 45. So let me write it down. F24 cos 45, right? And since it is pointing in negative x direction, what I'm going to do? Apply a negative sign. Now, also in in x direction, there is also this guy F21, right? So F21 in negative x direction, that's why again negative. Now, in y direction, who are present? F24 sine 45. So F24 sine 45. Can you guys tell me what sign should I put here? What sign should I put here? Positive or negative? F24 sine 45. Is it positive or negative? Can you guys tell me? Positive or negative? In what direction is it pointing? It's pointing in positive y direction now. So it is positive. Is that clear? Now, another force pointing in y direction is F23. So it will be yet again positive F23. Now substitute the values here. Substitute the value. F24 is gm square by 2a square. So minus gm square by 2a square minus F21 is gm square by a square. If you take LCM and minus minus, if you add them, so it will give you 3gm square by 2a square into 2 into 2. Yeah, 2 plus 1, 3. Yes. So this is in x-axis. Now for y-axis, what we have to do? We have to calculate in the same manner. F24 is gm. Oh, okay, okay. One thing I forgot. I forgot to write the value of cos 45. I was very excited to solve the question and I forgot to write the cos 45. No issues. We'll include it here. We'll include it in the denominator. Cos 45 is 1 by root 2, right? So that will be equal to 2a square or 2 root 2a square. 2a square was already present and root 2 got included. So our final answer will also change. We'll take common g m square by a square will take common and negative sign as well. Inside we are 1 by 2 root 2 plus 1. This is the only thing remaining inside, right? Now for this guy, F24 is gm square by root 2, sorry, gm square by 2a square, and since there is sine 45 also, that's why I'm writing it as yet again 2 root 2 a square plus F23. F23 is gm square by a square. So what will happen? Yet again, if you solve this, you'll get the same value. Gm square by a square will get out as common 1 by 2 root 2 plus 1. Okay, so in x-axis, these are the total force acting in x-axis. What did we get here? Total force acting in x-axis. This is it, right? And what is this then? This is the total force acting in y-axis. Hopefully this is clear, right? Now, So just using the resultant formula, that is under root x square plus y square. So since both of them are same, I'll give you one trick to solve such questions when you have to solve x square plus y square in under root, and x and y, both of them are same. Okay. So both of them are same. Let's say both of x and y have, for example, have the value a. So what will happen? A square plus a square under root. So you'll solve 2a square under root. That will give you a root 2. So basically, you just have to write the value here and multiply it by root. As simple as that. Write the value, multiply it by root 2. So let's solve for our use this trick for our question here. R is equals to, what is the value? Gm square by a square and bracket 1 by 2 root 2 plus 1, right? This is the common value and you just have to multiply it with root 2. Is that clear, guys? Is that clear? Is the trick clear? Yes or no? Okay. So what will we get? R is equals to, just multiply root 2 inside, gm square by a square and 1 by 2 plus root 2. So this is our final result. Means the total force acting on that mass is given as this. Hopefully this is clear. Is this question clear, guys? Is this question clear? We'll move on to next topic. Is this question clear till this point? Does anyone has any doubts? Please let me know. Is this question clear? Yes or no? Is this question clear? Hopefully this is clear. Okay. So let me give you an homework question. The homework question is okay. Let me. Oh ho ho. Wrong color. Okay. So the homework question is. So this is an equilateral triangle. All right. Yeah, doesn't seem so though, but this is an equilateral triangle. Believe me, this is an equilateral triangle. Now I'm keeping three masses on the corners. All the three masses have same value m, m, and m, and the side is a. Okay, the side is a, and a. You have to calculate the total force on this guy, this upper top mass. Calculate. Write down this question. Calculate total mass. Sorry, total gravitational force. Total gravitational force on shaded mass. Okay, shaded mass. It's shady in nature. Okay, so hopefully this question is clear. Just I'll give you the hint. I'll give you the hint, guys. One force will be due to this and another force will be due to this. The angle between these two forces is 60 degrees since it is an equilateral triangle. Find these two forces and find the equivalent between them using the formula. What's the formula for equivalent? That is R equals to under root a square plus b square plus 2ab cos theta. Use this formula and solve it. Okay. Hopefully this is clear. I have given you the hint. We'll solve this first in the next class. Okay. Now, let's move on. There was something I want to talk about before heading on to the next topic, that is binomial expansion. Okay, let me, I'm giving you 5 seconds to take the screenshot of this page. It got messier, but I think we can work with it, right? Okay, I'll try to write in a cleaner manner going forward. Okay, 1, 2, 3, 4, 5. Okay, I am removing all of it. Okay. Now, so binomial expansion. So one special binomial expansion, I'm not going to teach you the whole chapter because it's part of mathematics, right? NCR, x to the power n minus r, a to the power r, right? So the special case of it, which in physics we use very often, 1 plus x to the power n. This is given as 1 plus nx plus n into n minus 1 x square by 2 factorial plus n into n minus 1 into n minus 2 upon uh, x cube by 3 factorial and so on. This is very important relation. Please write it down. Please note it down. Okay, we are going to use it in the further derivations. This is very important. Note it down, guys. Note it down. And the best way to attend the class is just note down with me. Okay, that is the best way to do it. Taking screenshots in emergencies is okay, but don't make a habit of it. That's not very healthy, to be very honest. Okay, so like a kid, I'm coloring this whole thing, right? Okay, so this is very important formula. Let's move on. Let's move on to our next topic, that is acceleration due to gravity. Is everything till this point clear to you all? Is everything till this point clear to you all? What have we studied? We'll see introduction, we saw universal law of gravitation, we saw. We also saw the vector form of this force, right? We saw what is unit vector, and we did a question in which there were 4 masses, and on this mass we have to calculate the equivalent potential. Sorry, equivalent force, resultant force we have to calculate. Then we saw a binomial expansion for a very special case, that is 1 plus x to the power n, that is equals to 1 plus nx plus n minus 1 x square by 2 factorial plus n minus 1 n minus 2 by 3 factorial x cube, and so on. Now, there's something I want to discuss, that is called acceleration due to gravity. What is acceleration due to gravity? So it's very simple. Okay, so we just now studied F is equals to G m1 m2 by r square. What is this G m1 m2 by r square? For example, for Earth I'm talking. For what I'm talking? For, let's say, Earth I'm talking. Okay. Let's say for Earth I am talking, and let me make an Earth real quick. All right. So please forgive my drawing. I'm not very good at drawings. So this is our Earth. Okay. Yeah. This is the whole blue color section. Why I bothered making it now, I'm thinking. And this is the green or the part. Okay. Hopefully this will do. Now, now, for example, some guy is standing on the surface of the earth. You can also stand on the surface of the earth, right? But not as big as this guy. This is a humongous guy. Is standing on the surface of the earth. So what does this? So first mass is that guy. Let's say m1, and the second mass is our earth. Yes or no? And the distance between these two is r. Is that clear? First mass is m1, the guy. Second mass is m2, and the third mass is the distance between these two. Is that clear? Now, what we are going to do, we are going to see, just a sec, guys. Yeah, I'm really sorry for that. Now, what I want to calculate is how much force is Earth applying on this guy. Okay, so it is simple. G m1 means mass of guy, m2 mass of the earth divided by r square. What is r? Let me write it down here properly. R is the distance between the guy and the whole earth, that is r square. So radius of the earth, right? Also, we have studied in Newton law key on the surface, this the force on this guy will be equal to m1 g. What is g? Acceleration due to gravity. Can I equate these two? This is also force due to the earth. This is also force due to the earth. So g m1 m2 by r square will be equal to m1 g. Yes or no? So m1 and m1 means mass of the guy, mass of the boy will gets cancelled out. And what is this remaining here? Can I write g is equals to g mass of the earth divided by r square, right? If you substitute these values, 6.67 into 10 to the power minus 11, mass of Earth, mass of Earth has some values which I'm not sure, but I'll tell you in a minute. And the radius of the Earth is 6,400 kilometers. Changing it into meters is 10 to the power 3 divide ka whole square. So that will give us, if you solve this, 9.81 meter per second square. Hopefully this is clear, guys. Is this clear to you all? Is the acceleration due to gravity clear? Yes or no? Is the acceleration due to gravity clear to you all? Just give me a thumbs up. Why? Yes. Whatever. Just give me an indication if it is clear. I'll just tell you the mass of the Earth. That is, yeah, almost close to 6 into 10 to the power 24. Just solve it, you'll get this answer, right? Now, so acceleration due to gravity, we have gathered the numerical value and also the formula. The formula is gm, mass of Earth, by radius of Earth whole square, and on solving we'll get 9.1 meter per second square. And also I'll give you another form of this, 32 feet per second square. This is also important in certain questions when you will solve HC Verma. This unit you'll use a lot. 32 feet per second square. Hopefully this is clear, right? Now, moving on to variation of G. What is variation of G? Okay. So let me just go to, yeah, this diagram. I'll just use this diagram. Okay. So what happened in the previous case? Our guy was standing on the surface of the Earth, right? What if he goes far away from the surface of the Earth? Here in the space, just flying off in the space like this. So what will happen here? And what if he dug inside? What if he with the very patience he dug inside? Okay, a tunnel which was, let's say, somewhat inside like this. So what will be the value of G for this guy? What will be the value of G for this guy? And what will we calculated the value of G for this guy, right? 9.81 meter, 9.8 meter per second square. So will the value of G change for this one who is far away from the Earth? And when the value of G change for this guy who is inside the Earth? Okay, so that we are going to see in the next class. For the time being, I'm just giving you a question. Okay, let's solve a question. A recall question we'll solve and then we'll end this class. I'll just write down the question real quick. No, not this one, not this one, not this one. Yeah. A mass, I'll write it down somewhere up. Yeah, I'll write it down here. A mass, question is, note it down with me. It is a good question. A mass M is at a distance, a mass M is at a distance A from one end of a uniform rod of length L and mass capital M. Find the gravitational force on the mass, find the gravitational force on the mass due to the rod. Okay. So what is the question saying to us? Let me solve this question. Okay, I'll solve this question for you guys. There is a rod. This is our rod, let's say. Okay, this is our rod. Now, what this rod is doing, the length of this rod is given as L. Okay, and a mass M is at a distance from one end of a rod, means एक mass M है, there is one mass M. It is at a distance of A. It is at a distance of A from the one end of the rod. Okay, or this is small m, and the mass of the rod is capital M. The mass of the the mass kept beside the rod is small m, and the mass of the rod itself is capital M. Now, this whole rod, since it has some mass, since this ball, let's say our ball has some mass, these two will attract each other, right? So how much force will this rod apply to this ball? Is the question clear, guys? Is the question clear to you all? Now, since Newton's laws of gravitation is only valid for point objects or spherical objects, okay, not for these continuous objects. So what I'm going to do is I'm going to take a small part, okay, a small part here, which has a mass dm. I'll cut a small part which has a mass dm, and it is x distance away from our ball, and it has a width of dx. So what will be the force due to this small dm? So force equals to mass 1, that will be our ball ka mass, g small m, into mass 2, that will be our rod ka mass, dm. Dm means small mass, okay, and upon x. So what is the distance between these two? That is x square. Hopefully this is clear. Now, since this force is due to this very small mass, na, so this force will be df. Now, how do we calculate total force? Chota force, small force, we found out, right? If I add all these small forces, what will I get? I'll get the total force, right? If I add one force from here, one force from here, one force from here, one force from here, what will I get? I'll get total force, right? So for adding, what we do mathematically, we integrate. For adding, what we do mathematically, we integrate. So F is equals to G is constant, mass of this ball is constant, dm by x square. Now, can we integrate this? No, we can't integrate this because dm, what is dm? Mass. Okay, we have to integrate with respect to mass, and our variable is x square. Those two are two different quantities, two different variables. We can't integrate that, right? So what I'm going to do is I'm going to use the concept of mass density. What I'm going to use? Mass density. What is the formula of density? Mass by volume. But what if the mass is, what do you say? Mass is distributed along a length. What will happen back then? Then that will be equal to mass by length. All right. So mass density is denoted by lambda. Okay. Since it is only distributed along a line, okay, for this rod, I'm using linear mass density, which is given as lambda. Okay. What is total mass? Capital M. And total length? Capital small l. Or can I say small mass upon small length dx? Chota mass upon small length dx. So what is the value of dm comes out to be? See, using these two, what is the value of dm comes out to be? From this, we can calculate the value of dm as m by l into dx. Just substitute the value there. F is equals to gm m by l into dx divided by x square. Since this quantity m by l is constant for a rod, right? So that will give us gm square by l into integration dx by x square. Okay, now this small element, first where can we calculate this, put this small element? We at the initially we can put this small element here, and at the end we can put this small element here. So what will be the value of x? What will be the value of x if I take a small element at this extreme? That will be a, right? What will be the value of x if I take this at this extreme? That will be a plus l. So the limits are a to a plus l. Hopefully this is clear, right? Initial value a, final value a plus l. So that will give us gm square by l integration of x square, x to the power minus 2. It will go up minus 2 integration plus 1 minus 2 plus 1 a say a plus l. So that will give me gm square by l, and this is minus 1, right? So I'll just put a minus sign aage in front, and that will be 1 by x, a to a plus l. Hopefully this is clear, right? Now, yeah. Okay, one thing I would like to correct myself is this is small m, right? While going down, I converted that into capital L. So here, this will be small l. Small m into capital M. Small m into capital M. Okay, so I'll just correct it here also. Small m means mass of ball and mass of our rod. Mass of ball, mass of rod. So just substitute the value, just replace. The force will come out to be minus G small m capital M by L, and that will be equal to 1 by A plus L minus 1 by A. First put the upper limit. First put the upper limit in place of x, then put the lower limit in place of x, and then subtract these two. Minus G small m capital M by L. And if you take LCM, it will come out to be A into A plus L, A minus L. So this will give you F is equals to, these two will cancel out each other. This minus and this inside minus will cancel out each other. So that will give you F is equals to G small m capital M by L into L by A into A plus L. Again, this L and L will also get cancelled out. So F, the final expression will be G M M by A into A plus L. Now, to be very honest, it seems very hard, but it's not. Trust me, it's not. It's very easy. Once you get a hang of it, now, if you revise it multiple times, you'll see how simple it is. You are just going to repeat the same process for all the type of questions. Same thing again and again, and you'll get a hang of it. Hopefully, this is clear. So again, let's see what we did in this question. The question said a mass M is at a, this is our mass M, let's say ball, is at a distance from one end of a uniform rod. It is at a certain distance from one end of a uniform rod. Okay. Let me just redraw the rod. Okay. So this was our rod. This was our rod. Its mass was capital M. Its one end was a distance and the whole length was. Now what we did was we took a small element here. We cut a small element here. Okay. Its mass is dm and its length is dx, and it is x distance away from our ball. Okay. So due to these two forces will be equal to very small force df is equals to g small m into dm by x square. Now, since G and M are constants in this case, G and M are constants, I just took them out of integration. Now, I'll integrate both sides to take the whole value. So, df integration will give us f, and inside dm by x square. Now I take the, since the mass is distributed lengthwise, so lambda is equals to m by L, total mass by total length, or small mass by small length. So the value of dm will be equal to m by L into dx. I substituted the value here, and since m by L is constant, it will come out small m into capital M by L dx by x square. Now, where is the first element I can cut? The first element I can cut on this rod is here, right? See this part. And the second element I can cut is here, this part. So the first element, the distance between the value of x for first element is a, and the value of x for the last element is at the very end is a plus L. So the limits turned out to be a to a plus L. We integrated it, and after that, a little bit of solving using LCM, we got this answer. Hopefully this is clear, guys, right? Now, let's see what we studied today. First, we saw what is gravitation. Gravitation is when two masses are present, okay? They apply a unknown force on each other. We don't know the origin of that force. They apply a force on each other, an attractive force on each other, okay? Newton didn't knew the, origin of that force. But right now we do, and that's your homework to find out what is the origin of that force. Then we saw Newton's law of gravitation, F is equals to G m1 m2 by r square. G is universal gravitational constant. The value of G is 6.67 into 10 to the power minus 11. Unit is very important, Newton meter square per kg square. Dimension of G, we calculated using its unit. Hopefully this is clear. Using its unit, we calculated the dimension of G. Then we saw vector form. For vector form, we just multiplied it with a direction, that is unit vector. Okay. Calculated, we solved this question, right? And I also gave you a question related to a triangle. An equilateral triangle of side A, mass is M. On the top mass, you have to calculate the total force. After that, we calculated 1 plus x to the power n. What is the value of that? Binomial expansion. 1 plus nx plus nn minus 1 x square by 2 factorial, nn minus 1 n minus 2 by 3 factorial x cube, and so on, which we will use in the next class. Acceleration due to gravity, we calculated. Two forms we saw. One numerical form, which has two values, 9.81 into 9.81 meter per second square or 32 feet per second square. And the formula for it is G, mass of Earth upon radius of Earth squared. We solved this question. So that's it for today. In the next class, we are going to dig deeper into this, as we saw here. What will happen to the value of G if we fly off into the space or we go inside the Earth very deep. Okay, so we are going to start tomorrow's class with that note. Till then, keep studying, keep solving questions, and for any problem, do reach out to us. Okay, so bye bye, guys. Yeah.